Hello, Java programmers. Let's continue our discussion of arrays and array lists. We have very often in our programs the opportunity to manage data that is logically related. We have a whole accumulation of names or addresses or people or courses that were taken or roads in a township or medical procedures that were performed. It's very convenient to group these homogeneous, logically related things together into a data structure rather than creating individual variables to represent each of these individual elements. Two data structures available to us are arrays and array lists. They overlap, but they also have individual advantages over the other. And it's important for us as programmers to have a thorough understanding of data structures to allow us to pick the correct one when we begin writing code. You're all doing great. I appreciate everyone's participation. Please stay in touch with me. Let me know how you're doing. Reach out if you need help. You know how to do that. And Sirius the cat is also proud of you. He's providing some encouragement here. He wants you all to become really good programmers so you can write programs about kitty cats. When you're writing your code, logic is important and the soft skills are important, like formatting, documentation. Programs are written once and read many times by other people as well as by the author. You're going to write programs to put into code repositories for use by your group and other groups, and who knows who around the world may be looking at your program. It's in your best interest to document your work and follow some basic standards to allow other people to jump in and understand what you're doing more easily. Java docs should be provided for all the methods that you write except the main method. We know what that is. But define the method description, provide a simple synopsis of the inputs and the output, if any, and also format your code correctly, and correctly is in quotes. Format your code according to some standard. I have provided guidelines in this class for formatting. Undoubtedly, when you go to work as a developer or you work with developers, there will be different styles. You may have a style imposed upon you. You may be left to flail and develop your own style depending on the attitude of the company. Typically, a larger company has more conventions and requirements than a smaller company, but you never know. You may even be asked to provide input on coding standards or revise a dated coding standard. Therefore, it's important to have a good understanding of what's important when we write our code as far as style. If you do it, if you're hands-on, then you can speak to whether braces are important or whether tabs are important or whether we should have methods that fit on a page so they're easy to read without scrolling up and down. If you just talk about those things without doing them, then you don't have nearly the understanding. I can sit here and lecture you all day about replacing the brakes on your car, but until you actually get next to the car and do it, you'll never have an understanding of how it works. Same thing in coding. Don't just listen to me. Open up Eclipse and write some code, and that will give you hands-on experience that will carry you much farther. In our discussion of arrays and array lists and even other data structures, we're concerned about when we should use them. Here are some general guidelines to follow. If you're given some pseudocode, if you're asked to solve a problem and you have data to manage inside of your code, if you have a fixed number of items that's not going to change, if all those items are homogeneous as far as data type goes, if they're all strings or they're all ints or they're all booleans, then an array might be a good choice for you. An array is faster than an array list at execution time because an array is laid out in a linear fashion in memory. One element follows the next to the end of the array. Whereas in an array list, things may be scattered throughout memory and connected to each other via memory addresses. Without getting too far into the weeds, if a data structure is laid out in a linear fashion in memory, it will be faster to traverse and faster to access. If you need total speed, then an array is definitely preferable over an array list. If you need to grow and shrink the data structure over time, if you're adding and removing things like crazy, then an array list would be the choice because an array cannot grow and shrink. Once you've determined the size of it, when you instantiate it, then you can't grow and shrink it after that. You can throw it away and start over, but that takes time too. Therefore, we have considerations of time, which means execution time. How long does it take to run our program? And that usually abstracts into a term called efficiency. But really, we're talking about allocation of resources. How do we use the CPU? How do we use all the cores? And how do we use memory? And those two things characterize the efficiency of a data structure. Some things that we can do to these data structures or do with them, we can sort them, and we will see shortly that we don't have to write a sorting algorithm. We can search through them for something, a particular value, a max, a min, a target. We can iterate over them, which in some cases may be part of the search. We can edit the individual elements in them, and there are some data structures that are not editable. Once you add an element to that data structure, you cannot change it later. Arrays and array lists do not fall into that category. And we can add, append, and delete elements if we're using an array list. We can't do that with an array. There are more things we could do. We can convert it to a different type. We may convert an array to an array list or vice versa. We may convert an array to a hash table. We may convert an array list to a tree structure. But here are some basic things that we probably want to do very often. We talk about solving problems by using a search engine. And reading the book is crucially important. We still don't diminish the significance of books. We still also want to develop the skill of looking for problems online or looking for solutions to problems in order to work a little more efficiently. And as we've learned, software technology as a whole changes so quickly that very often you can't find a solution easily in a book because there is no book. So, yeah, it's a good idea to be able to Google solutions to problems, but it's also going to be to your heavy advantage to be able to do these things out of your head. If you find yourself after 6 months on the job still Googling how to iterate over an array, You probably need to sit down and commit that to memory because you're just slowing yourself down. The way I think about the problem from a grand scale is that every time I have an array or an array list, I am almost always going to loop through it. Both these data structures are completely adapted to iteration, and we very often print them one at a time, or edit them one at a time, or copy them one at a time. And to do that, we need a loop. So have that kind of syntax available at your fingertips at all times. The most basic looping structure is provided on this slide. If we want to step through an array, we use the length property of that array. We start at 0 and we go up to length minus 1. In this case, we're saying for I equals 0, I less than the length of the array, and then I plus plus each time we go through the loop. There's boilerplate. There's standard programming syntax for stepping through all the elements in an array. And it also works for an array list. It's just determining the length is slightly different. We also have the technology, which is not completely new to Java, but was introduced in a version of Java. It didn't come along in the original, the concept of an enhanced for loop, which lets you drop the index variable so you don't have to worry about managing that I anymore. And because of that, you don't have to worry about the indexing notation either. You don't have to worry about the square brackets. So let's go back to our coding platform. And I know I have it here somewhere. There it is. Let's create another project. I'll call the project Arrays and ArrayLists because we'll be touching on both. And I'll throw myself a main class, a main method, a main package. We'll just call everything main, 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 main. None of those names matter except for the main method because that's the entry point to our code. That's where it starts to run. But we could call the class anything. We could call the package anything. All right, and get rid of the to do because we know what we need to do. And let's start out by creating a little method to place our code in. Whoops. Public static void demo. And then in the main, we will call that method just to help us segregate our code a little bit into logical blocks. We could jam everything into the main, but the main would get excessively long and it would be problematic to talk about. Therefore, we'll just break it up into methods. This is your approach for the rest of your career, is modularizing your code into classes and methods. We don't know anything about classes yet. We are skipping the topic of classes in any level of detail until we get to the next course in this sequence. All right, let's create an array and an array list, and then we'll do an enhanced for loop over both of those. So I will say my array will be string alpha. Whoops, forgot my empty brackets. And it has a new string 10. You should recognize this as declare and instantiate. The declaration step tells Eclipse the name and data type of the variable. The name is alpha. The data type is an array of strings. The instantiate is set aside memory for 10 string elements. We can highlight the different parts. The declare part is string open bracket close bracket alpha. The instantiation part is new string open bracket 10 close bracket. Those can be on the same line in the same statement, or they can be separate. In this case, it's convenient just to combine them together. Now we don't have anything in the array yet. Let's just put a couple of silly things in there. We'll put pizza in. We'll put chili in. We'll put hamburger in. And we'll put gosh, I'm out of foods. Sandwich. I have declared and instantiated an array of 10 strings. I have only initialized the first 4 of those strings. The other 6 are uninitialized. You can think of them as null or empty. And then let's make our array list. And let's have this one mirror the same contents. Let's call this beta. We'll do our declaration and instantiation on the same line as we did with the string array. And when we type in this code, we immediately get a squiggle because Eclipse doesn't know what an array list is. It's not a built-in type. It's not native to the language. It has to be brought into our program using an import statement. This is one of the first instances or examples of a class that we're using. And data structures are typically implemented as classes. An array is native to the language. It's just the open and close square brackets. An array list is a class, and you need to import the definition of that class. Eclipse offers to do it for you, and that's the first fix in the list of fixes that I get. You'll have to look closely at your list. You may get other fixes that I have. That's a function of what I've got installed on my machine. I have probably a lot more libraries installed than you do. And Eclipse may go through and find suggested fixes in the set of libraries that are installed on my computer, and you may not have those. You should get that import ArrayList fix. And it should be the very first one. If it's not, for some reason, you can just type in the import statement. Some people are in the habit of just typing that in because they know they're going to need it. Some people are in the habit of letting Eclipse offer to fix that. Once you've imported that definition for the ArrayList class, the errors go away. The red squiggles are gone. The only problem now is just a warning. It's a yellow squiggle, and that is because you haven't used beta for anything, which is fine. That's true. We haven't used beta for anything. So the warning is legit, but it will shortly go away. Let's annotate that we are declare and instantiate. In that line of code. And then we need to add the same contents to our array list. We'll just have them mirror each other for demonstration purposes. Now, how do you add something to an array list? Notice that When I instantiated this little guy, I did not define a size. When I instantiated the array, I defined it as a size of 10 strings. It grows and shrinks as necessary. Behind the scenes, if you were to open the cover of your computer and get out a microscope and look at the RAM, you would see that it actually allocated space for, I believe, 10 strings when I instantiated that array list. But as far as the program is concerned, it has nothing in that array list. It's empty. It has 0 length. It does allocate some space, though, because it knows you're going to come along later and add elements to that array list. But that's an under the covers thing that we're not worried about. Right now, as far as we're concerned, that array list is 0 length. It has nothing in it. We add to the array list by selecting the add method. And I can put in pizza. And that makes the array list now contain one element, one string, and that string is pizza. Then we can just follow through and add the rest of these. The second one was chili. The third one, hamburger. The fourth one, sandwich. So at this point, now both data structures have the same contents, whoops, because we wrote them that way. All right. As far as Eclipse is concerned, I'm going to be more specific. As far as Java is concerned, Eclipse is just our editor. Both of them contain pizza, chili, hamburger, and sandwich. And I can print out the size of each one. So I can say alpha dot length. Now, there's a mistake here that I just made. If I try to put parentheses on length, if I try to use it like a method, it doesn't know what that is. But if I take off the parentheses, it's fat, dumb, and happy. And it says, oh, I know what that is. That's the number of elements currently in the array. And then I can print the length of beta, which is an array list, but it's not length anymore. It's size. And it has parentheses. So we call this the size property, and we call this the length property. Even though they look different, even though the length is actually an integer value and the size is a call to a method, we can refer to them as properties. And we're using the term property loosely here. Now when we run this, we should get the same number for each. Let's make this a little more friendly. Number of elements in alpha colon plus and number of elements in beta colon plus. They both should be 4. Pizza, chili, hamburger, sandwich. But they're not. See the difference? In our mind, when we read the number of initializers, we think 4. But when we instantiated the array in line 12, we asked for 10. There's really 10 elements in that array, even though we've only used up the first 4. In the array list, there's 4 elements. What's going on under the covers might not be the same, but as far as we can tell, there's only 4. So that's a little bit weird. There's a kind of a different behavior between those two data structures. We committed to 10 elements in line 12. We are stuck with that number, even if we only use the first 4. Is that wasteful? From a microscopic perspective, yes, it's wasteful. We wasted a few bytes. If we were very concerned about bytes, we would have to consider that situation. If we had limited memory in our computer, that would be a problem. Now, if we don't, we have gigabytes of RAM, and we're writing little tiny programs. If we were programming something like maybe a weather station that sat in your backyard, then maybe when they build that hardware, they spend as little as possible on parts so they can make a profit, and they minimize the amount of RAM added to that little device that sits out in your backyard and reads the temperature and wind speed and barometric pressure. And you might be horrified to find out that you have this little tiny amount of RAM. And you can't just allocate arrays without thinking, because you might run out of space. The good news is if you run out of space, you'll know about it. Something bad will happen. But that something bad might not happen until you're well into development, and it might be really hard to recover from that. That means in the back of your mind you are simply keeping track of how much memory you're using, and you're aware in general of what your resource allocation is and what your needs are. Now in the case of the array list, we got a 4, but even then there's things going on behind the scenes that we don't know about. But we're not going to discuss that here. That's beyond our scope. Okay. How do I loop through these things? We were talking about using loops, and in the case of arrays, a for loop is very convenient. We could use a while loop or a do while loop, but we typically use a for loop. Let's start with print the contents with an enhanced for loop. And we'll do 2 of them. They look pretty much the same. For string s colon alpha curly brace system dot out dot println alpha sub, oh, it's s, I'm sorry, s, there we go, closing brace. There's an enhanced for loop. It looks a little bit weird. It's got the word for in it, but it doesn't have the 3 loop structures that you're typically used to in a for loop. It just has what appears to be a variable declaration, and it is. We're declaring a string called s, and then a colon. Finally, the alpha is what we want to iterate over. We want to iterate through the elements of alpha one at a time, starting from the very first one we put in out to the last one. And then the loop body is a simple print statement to print. The s can be anything you want. We can call that element. Doesn't make any difference. As long as it's a legitimate variable name, we can call it pizza. We can call it Bob or Fred, Carol, doesn't make any difference. When we run this, we get 4 lines of output plus 6 lines of null. So there is a potential problem with an array because the array is defined as having 10 elements. Let me try to get all this on the screen. The array is defined as having 10 elements. We only initialized 4 of them, and there are the 6 null values I talked about a moment ago. We don't have any way to control that in this enhanced for loop. It's okay, it's just something you have to be aware of. Now let's do the same thing with the array list. We'll just call this E colon beta, and we'll do another print statement. System.out.println E. That's going to give us just the 4 elements we put into that array list because there are no other elements. Run. There are the 4 elements, pizza, chili, hamburger, and sandwich. So they both work. The enhanced for loop is fine, no problemo. But if you do that with a regular array, you're going to get all the elements even if they haven't been initialized. We could clean this up a tiny bit, potentially, by putting another statement in here. If E equal null, about this, break. I messed up. It's not E anymore. It's element. Now I'm saying when I get to the last one when I get to the first one that doesn't have data in it, I'm going to give up. I don't need to mess with those anymore. So we like these enhanced for loops because it lets us traverse the data structure and we don't have to worry about that array index, that I, when we use a regular for loop, because we don't have to maintain I equals 0, I plus plus, all those things. But there is a disadvantage to this. There are some things you can't do. So let me demonstrate. I'm going to modify this first enhanced for loop. And I'm going to say I decided to change all the elements to food. Let me clean this up just a little so you can see where the braces are. Okay. Now I'm saying let's go through the loop one element at a time, just as we did before. Each time through the loop, though, I'm going to just replace each element with food. So I'm just illustrating that you can, in concept, in theory, change the values in an array, but I'm trying to do it in an enhanced for loop. And let's see what happens. So it changed them all to food. Food, 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 food. But did it really? Did it really change them all to food? The plot thickens, the tension increases. Let's just try another print statement after the loop, system.out.println, and let's just do this. Can I just print the whole array by just referencing the array name? Okay, a little tangent here, but I'm curious. Let's put a label on this. Let's see. The array is now there. Can I do that? I don't know. What if I just reference the name of the array? I don't even use toString. I just say the name of the array. What do I get? Nah, I got garbage, which to us looks like garbage. It's actually the unique identifier of that array in memory, but you can't do that. So that's not going to work. But what if I say array.toString? Let's try that. That's maybe closer to what I want. Let's find out. That didn't work either. So I can't use the toString, and I can't reference the name of the array, but so I've got to have another loop. Okay, but I still want to print the contents of the array. Let's just print the first element. We don't need to see all of them, right? If it changed the first one, then it certainly changed all of them. So system dot out, whoops, dot print line, array sub 0. Well, it's not array. It's alpha. Ah, lost my train of thought. Okay, so that's what I want, right? Let's try that. Kaboom. Look what I got. You can't really tell because I didn't label my output very well, but I got pizza. I did not get food. To make it more clear, let's put a label here. Alpha sub 0 equals, there. You'll be able to see it now. Let's review what I did. I wrote an enhanced for loop, yada, yada, yada. Inside the enhanced for loop, each time I step through the array, the next value in the array goes into the thing called element. So I've got this variable called element. The first time through the loop, it's going to be pizza. The second time through the loop, it's going to be chili. The third time through the loop, hamburger, and so on. But I had a change of heart, and I decided that every element in the loop should just be changed to the word food. My program has become more generic, and they're all foods. Okay. In my mind, what I think is happening, I am changing all the elements of the original array to the word food, but I'm really not. See? Look at the output. The original value of the first element of the array is still pizza. So what I'm trying to tell you, this roundabout way, is that you can't edit the array in an enhanced for loop. You've lost that capability. If you need to edit the array, if you need to change the values in the array in the loop, you've got to use a traditional plain old for loop. You can't use an enhanced for loop. That was the takeaway from that. And so I will add a comment here just to clarify. I will say we cannot edit array elements when we use an enhanced for loop. And I'll put an exclamation point after that because it's kind of interesting and important. Let's try the same thing down here in the array list. Let's do E equals just food. Okay. Same thing, enhanced for loop. Each time through the loop, the variable E will be populated with the next element in the array list, pizza, whatever they were, chili, hamburger. Assign a new value to that element, print it out, but then when we get down here, let's jump to the chase, system.out.println, and I can do a whoops, if my cursor will stay in place, I can do a beta is now plus beta dot toString, and toString should be more friendly in this case. Again, focus on this code right here. Step through the array one element at a time using an enhanced for loop. Assign each element the value just food, theoretically overwriting what's in beta, but it's really not. And let's see what we get. To clarify the output a little bit, we are getting cluttered. Let's just put in some stars. How about that? There we go. Let it rip. There's our output. As expected, it did not change the original contents of the array list. When I print the array list at the bottom, after the enhanced for loop, it's still got pizza, chili, hamburger, and sandwich. That's our takeaway, that we cannot edit elements in an array or an array list using an enhanced for loop. So that will drive you nuts if you try to do it. When you design your software, make sure that you're aware of that restriction and you take steps appropriate to get around that if necessary. Whoops, where are the slides? There they are. The answer to the question then, or an answer to the question, is if you need to edit the elements in the array, do not use an enhanced for loop. If you need to edit the elements in the array, use a plain old vanilla for loop. And I made up this term, plain old vanilla. Enhanced for loop is our technical term. It's a programming construct. Plain old vanilla is made up name from me. So as we go through these examples, just a reminder, be sure that you're cognizant, aware of the data structures that I'm using. And I posed a question on the slide. We have, let's just say we have a terabyte, or we have 2 billion data points. We need to store those and find the maximum and the minimum. I have this large data set. It's the salary of every person who's ever lived, or it's the address of every person who's ever lived, or it's just it's the temperature of every point on the earth. I don't know. How do you process that? I'm told that I need in my program to store all of those data points, and eventually I'm going to have to find the maximum and minimum values. So as a thought experiment, you should think about what the appropriate data structure might be. One consideration you could make is, well, as I'm storing them into that array one at a time, why don't I just capture the maximum at that point? That would be a fair assessment of the problem. Hopefully that I have some control over how they're getting into that data structure and I can look at them one at a time. However, if they're already in the data structure and it's provided to me and they're not sorted, I would have to traverse it somehow. And traversing an array is much, much faster than traversing an array list. Because the array is linear, it's laid out in memory one after another in a contiguous fashion. And the data structure, the elements in an array list are not contiguous or linear, so that would be a problem. Here's another statement for you to review. I am giving you what kind of data type here. You should recognize this as an array. Recognize that we are declaring, instantiating, and also adding a third step, which is initialization, all at the same time. And this removes the burden of having to put a number in the instantiation component. We don't have to put 5 in there if there are 5 names. We can just put a blank in there, nothing. The initializers then determine how many elements are in that array. And that's kind of neat. So let's grab that code off the slide. Less typing for us to do. Let's go back to our project. Let's abandon the demo method because it's just gotten too cluttered. Comment that out. Let's write another method. We'll call this demo1. The method can go right below the main. Paste in that code right off the slide. It looks good. Resize my window a little bit to make it fit. Then I could do a print statement, system.out.println, and I can say names dot, remember the property that tells us how many things are in that array. It's called length. Does not have parens. You're not calling a method. You're just referencing a proper value. And that would be, I hope, 5. Yep, that prints out 5 because there were 5 initializers right here. That's where that 5 comes from. What if I put 6 in there? Now I'm saying I want a 6-element array of strings. Sadly, I'm only providing 5 initializers for that 6-element array. That makes Java sad. Eclipse gives you an error. Cannot define dimension expression when an array initializer is provided. In other words, even if you get the right number in there, even if I put 5 in there, it still won't let me do it. That's just Java being Java. Java holding your hand and saying, hey, that's kind of redundant. Let's not do it. The program simply will not run. It is now considered syntactically incorrect. Easy to fix. Read the error message closely. Cannot define dimension expressions when an array initializer is provided. All you need to do is take out the dimension expression. Now it works. You have 5 initializers. The array will have 5 elements. How about this for a method? Search for a last name in a list of names and print it if found. Let's try that. Grab that off the slide. Paste that in right below the main. Remember, all the methods that we're adding are separate from the main, meaning they have their own braces. They don't nest inside of each other. So the main method does not contain any of the other methods. The class called main contains all of the methods. Paste it in. It's syntactically correct. It has the right number of braces. It doesn't do anything. It accepts 2 parameters. But there's no logic in the method. We should fill that in, right? We should put something in there. So how about an enhanced for loop? Because all we're doing is searching and eventually printing. We're not editing the array. So we can use an enhanced for loop, right? We don't need that index number, that I. So for string s colon list. There's our enhanced for loop. We are stepping through or iterating over the array called list. Each time we go through the loop, each pass through the loop, S will be the next element in the list. And then we need to check to see if it finds the name. And we can do an if statement. If S dot is, how do you compare strings? How do you compare strings? Uh-oh, let's say I don't remember. Let's say I totally blanked out and I was listening to the radio and the Reds were playing and I wasn't paying attention. What if I use equal equal? If S equals target system.out.println S, that's what the method promises to do. It promises to print it if it finds it. But I used the wrong comparison logic. You don't compare strings using equal equal. You can compare numbers and booleans, but not strings. So I forgot. Oh no. But I realized it just in time. Before I start running the code and trying to debug it, I realized that that is not the way to compare strings. And it would be really, really nice if Eclipse gave me an error right here. But it's not an error. Okay, what we're doing there makes sense at some level, but not for the purposes of comparing strings. It makes sense on a different level that we're not going to go into. Your takeaway is that that is not the way to compare strings. I'll go back to my trusty search engine and I will say Java compare strings. I don't even have to scroll. I don't even have to click into these. I can see right there, there's a reminder for me. It says there's an equals method. Now I remember. Now I remember all the frustration I've had in the past trying to compare strings. There's a method called equals. I go back here and say s dot equals. There he is. I don't need the rest of this. This method returns a Boolean, true or false, and the if expression wants a Boolean in those parentheses, therefore I'm good to go. The method returns a Boolean, the if expression wants a Boolean. I don't have to do anything else. I could put equal equal true here, which is fine, perfectly fine, but not necessary. Actually, I would if it was my code. All right, I have a method I can call. Yippee, but I need to call it. Up in the main, let's comment out demo1. Let's call our method search for last name. The arguments need to be an array of strings followed by some other string, the list and the target. The array of strings, I'm going to cheat here. Watch this. I'm going to take this instantiation right out of this other bit of code. Be careful there what I'm copying. I'm copying the instantiation and the initialization steps. Okay? I don't need the declaration. Watch what I'm going to do with that. This is very tricky. I got the entire initialization and instantiation logic all the way up to but not including that closing semicolon. Watch what I can do. I can paste that right into the call to the method. Now it's not happy yet because there needs to be another argument, and I will put in the other argument will be Graham. I'm good to go. Closing semicolon. There it is. I can conjure up from thin air an array of strings and initialize it without even declaring it. How about that? That array of strings then is passed to the method as an argument. It pops into this parameter called list. Therefore, all of this stuff in line 9 that I've highlighted goes to list. And the second argument, Graham, goes to this parameter target. When the method executes, it's going to search through list, and it's going to search for Graham, and it's not going to find it because there are first names in there as well. Let's take out the first names so that it does produce some output. Let's run it now, and it should print Graham, right? Yay, it prints Graham. Awesome. Notice that it prints twice because Graham is in here twice. It finds the match 2 times. This is really fun and interesting. This is really cool stuff that we're doing, and this will help you a lot as you write more complex programs and you have to deal with more data. Very few programs have no data. There'll always be data. So it's important to always have some understanding of the structure of your data and be able to adapt it into data structure variables in your program. Slide 11, the topic of sorting comes up a lot when we want to create some output. Very often people want the output sorted alphabetically, numerically, ascending, descending. And if you have a large volume of data, you have some understanding, since you're writing the code, of whether it's sorted or not. You may have been accumulating data randomly. You may have been accumulating data from a temperature sensor in your backyard, and at night it's cold, during the day it's warm, the data goes up and down, but you'd like to know the maximum value in that data set, or the minimum, or even the average. Sometimes it's useful to be able to sort that data to process it more efficiently. The question comes up, should you write your own sort? Should you sit down and research how to sort things? And trust me, it is a very popular topic in computer science. How do you sort things? What's an efficient way? How do you use the least CPU time, the least memory to sort a set of data? In IT, in information technology, we are applying what's already been done, the research and the results of computer scientists. The short answer is no, you should not write your own sort. If you just have a need to sort data, there's probably already a way to do that. If you are a researcher, or you're just curious on a cold winter's day and you can't go outside, maybe you'd write a sort to teach yourself how sorts work and experiment. But strictly speaking, as a professional developer, no, you probably don't write your own sort. There's probably one already out there. Since we're using Java, we would revert to a search engine. You can see that when I typed in Java sort array of strings, I got a whole bunch of Google suggestions, because Google has seen many people make this search request. It's a popular topic. When I ran it for the purposes of creating this slide, I got 2.8 million results. I didn't look at all of them. I see in the very first one, there is apparently something called arrays.sort. And that's interesting, and I encourage you to do the same kind of search and investigate the results. I'll show you, if you want to take it a little bit deeper, that you can go to, I'm just going to say Wikipedia. Wikipedia has a lot of neat stuff about your favorite celebrities and who they married and divorced and what they earn and all their scandals, but it also has some good technical stuff too. One of the things that it does have is characterizations of different kinds of sorts, one of which is called a bubble sort. There's bubble sort and merge sort and quick sort, a whole bunch of different algorithms out there for sorting data. As a developer, do you care? No, not really. I'm off on a little bit of a tangent. If you want the experience, and I highly recommend it to you, Wikipedia actually provides pseudocode. You can take this little piece of P code and implement your own bubble sort. And that way you can put it on GitHub as part of your portfolio. That will show employers you are interested in your field and you have accomplished this execution of this pseudocode to create a bubble sort. Then you would go the next step and create a large data set, sort that data set, maybe optimize the sort a little bit, do an analysis on how long it took based on the number of data items, based on whether they were already partially sorted, There's all kinds of neat things you can do with sorting. But I encourage you to take that next step at some point, maybe in the summer when you're not taking classes, and look for some pseudocode like this and implement it because it will make you into a better developer. And it's not that hard. There's nothing in this pseudocode that we have not covered, believe it or not. There's nothing here beyond arrays and ifs and loops. And there's a method here called bubble sort. They call the method a procedure. That's just a generic name that encompasses methods and functions and subroutines. Again, something you could do, not part of the course, not required, just something that I suggest you take a shot at. From our perspective, then, we realize that there is a way to sort. It's built into Java. It's part of the arrays class. There's that word class again that we're skirting. We're not discussing classes in any detail, but the arrays class has a method called sort. You pass it the thing you want to sort, and it sorts it for you, which is really cool. Is it a bubble sort? I don't know. Is it a merge sort? I don't know. Is it a quick sort? I don't know. But it sorts. And for 99% of your applications, probably 99.99, it's going to be fine. There may be a situation, you may run into a situation where, oh no, this sort is incredibly inefficient and I can't wait for it to finish. It's just taking too long. I'm going to have to investigate other options. But for the most part, it works just fine for all of Java that you're writing. Let's go back to our code and modify it to use this sorting technology. And I'm all over the place now. I've got a lot of code, but it's scattered. So let's comment out the call to search for last name. And let's do a demo 3. We're really busy today. Demo 3. Whoops, don't want the comments, do I? Let's go down and write demo 3, public static void demo 3. Let's create something we can work with. I am going to simply grab this instantiation and initialization logic in line 9 of my program, take it right out of that code. Even though it's commented out, I can still copy paste it. Let's put it down here and let's say string names equals, there's my names, and I don't need gram anymore. I took too much, didn't I? I need that, and I need that. Okay. I have an array of 5 names. Let's put a couple more names in there just to make it more interesting. Patterson, Miller. 7 names now, 7 good strong names. Let's sort that. Watch how easy it is to sort. Arrays dot sort names. One extra paren there. How about that? If I didn't have the arrays class imported in my program, watch if I comment that out. If I comment out that import statement, I get an error because it does not know what arrays is. I can uncomment that and I'm good to go. To print it out, system.out.println names dot toString. Well, that didn't work for us before. Let's try it again. Okay, in my main, I call demo 3. In demo 3, I declare, instantiate, and initialize an array called names. Then I sort that array. Then I try to print it out using toString. I get that gibberish again. That's the unique memory identifier of that array, so that's not going to work. But I can do an enhanced for loop for string s colon names curly brace system.out.println s closing curly brace. There we go. The enhanced for loop steps through the array for each element. It puts it in S one at a time, then it prints out S in the body of the loop. And I should get an alphabetical list, right? There we go. Cheney, Graham, Miller, Nover, Patterson, Reynolds. Beautifully alphabetized. And that was one line of code. I called arrays.sort. As an information technologist, as a software developer, I don't care how it did the sort. I just care that it worked. You may be thinking, well, what if I want to sort in some other way, perhaps reverse alphabetical order? That is possible as well, but it's beyond us right now. It's not complex. I can still use the sort method. It just takes a little bit more work. So, again, it's possible. We're just not going to, we're going to skip over it right now. Good. So we learned how to sort an array. Now, let's take our array, and I'm going to show you how easy it is to convert that to an array list. The situation here is I have an array of strings. I like it, but I don't like it a lot. I want to change it to a different data type. All I have to do is call as list and pass it the name of the string array, and it will convert that to an array list of strings. This is a conversion between data types. Should you know how to do this? Yes, because sometimes you will need your data in the form of an array list. Other times you'll need it in the form of an array or some other kind of structure. Therefore, it's important to understand that data structure conversions can take place in your code. Let's copy that. And let's go back to, we're kind of stuck now. Let's see, we need a demo 4. Let's do a demo 4. We are just adding method after method here. Demo 4. Let's add our demo 4. Whoops. And I pasted in the code off the slide. That was slide 15. Needs a little bit of work. We're not there yet because I don't have anything called names in this demo method. So let's go back down to demo 3 and let's steal or borrow the names array. How about that? Copy. Paste it right above. That makes the error go away. In the demo 4 method, I have an array of strings called names. I have a conversion operation going on where I'm declaring, instantiating, and initializing an array list of strings called names2. Of course, the last thing we need is a print statement for string n colon names2 system.out.println n. We're going to get Cheney, Reynolds, Graham, Nover, Patterson, and Miller when we print. In the main, notice we're calling demo 4 now. Sorry, we're calling demo 4. What do we get? Cheney, Reynolds, Graham, Miller, Patterson, Miller. There you go. So we use the new keyword to instantiate a new array list, and the initializer to that array list was a conversion operation where it takes a list of strings and converts it to an array list of strings. Back to the slides. Can we add more names to our list? Well, we've already got Miller and Patterson in there. I jumped ahead on that. So we can add Sloan and Bailey. We've done this before. We did this a few minutes ago, but we can just add names dot add Sloan. Whoops, it's names too, sorry. And names to dot add Bailey. You can see now that it is possible to declare, instantiate, and initialize an array list of strings and then come back later and add 2 more elements to that array list of strings. We can do it both ways. Print it out. We're going to get those 2 extra names at the bottom. There they are, Sloan and Bailey, demonstrating concepts for manipulating array lists. Back to the slides again. Sort it out. You knew it was coming, right? How do you sort an array list? Well, we know how to sort an array. We did arrays.sort. Now we want to sort an array list. Remember, we're juggling 2 different data structures throughout this presentation. Should we Google it? Should we use our search engine? How do I sort an array list, or should we just take a shot? Let's go back to our code. And we'll just keep going with demo 4. We'll just keep adding to demo 4. We already have an array list called names2. Can I say arrays.sort names2? Apparently not. Apparently that ain't going to work because sort insists on having an array, not an array list. That's a problem. Ignore the part about int. That's a glitch in the documentation. So I need a different way to sort an array list. I can't use arrays.sort. So this won't work. Will not work because arrays.sort wants an array, not an array list. All right, we don't know. Back to our old friend, Java sort array list. I don't even have to drill down. Use the sort method of the collections class, not the arrays class. It's collections.sort. How about that? Back to the code. I think I can solve this problem. Collections.sort names2. Extra paren, get rid of that. I'm just typing in too many parens today. There's my syntactically correct call, collections.sort. Notice that I have import java.util.collections. I'm getting a lot of things from java.util today. I think, I'm not sure because I don't usually do this. I think I can do java.util.star, and I think I can eliminate these 3. That solves all three of those problems at the same time, importing everything in java.util. Now that's okay. It takes a little bit longer because I'm bringing in things I don't need, but that's also a common way to do imports. Where's my collection? There he is. There's my collections.sort, and to prove that it really worked, I need another print statement. I can use an enhanced for loop. There we go. Now this is going to push Bailey to the beginning because it starts with B, and it's going to push Sloan into where its correct location is in that sorted list. Let's try it. Remember, it's also going to print here. You're going to see output twice. I could comment this one out. Now it's only going to print once. Right there. Here we go. Get ready. This is exciting. There it goes. To sort an array list, it's collections.sort. That's the kind of thing that comes up in a job interview. They may ask you, how do you sort an array list? And the answer is collections.sort. How do you sort an array? The answer is arrays.sort. Sometimes they will expect you to have that in your brain because looking everything up just becomes way too inefficient. You can't look up everything. Some things you just have to know how to do. You'll get there. You probably aren't there now, but you'll get there, so don't stress out over it. Just be aware that there are things that you should know how to do. No one can tell you what they are until they're asked of you in an interview, but they are there. All right, back to the slides again. Go back and modify the search for last name method to print a message if the name is not found. That's pretty easy. We'll go back and do that. Search for last name is right here. We talked about that a few minutes ago. Now, how do I know whether or not I found anything? Well, the only way you know now is to look at the console window because programmatically I'm not keeping track. But let's make a little flag for ourselves. Boolean is found equal false. Let's assume that I'm not going to find it. But then inside this if statement, when I did find it, let's say is found equal true. Now I have a way of determining whether it was found. And then outside the loop, after I'm done searching, I can say if is found equal true. I can print out system.out.println found. The slide says print a message if not found. All right, to get that exact solution, I'm going to need to modify my logic a little bit. So I can go back here and say if is found equal false, meaning I never found, whoops. Then I can go over here and say not found. Okay, I will leave that as an exercise to you to test that. You'll have to go back to the main and uncomment out this to see if it worked. On the next slide, find the longest name in an array. Oh my goodness, that looks like a lot of work. Find the longest name. Remember, whenever you see array, think loop, traverse, traverse, traverse. What kind of loop should we use? We're not editing the array, we're just examining the contents, therefore an enhanced for loop is fine. This thing has a parameter, which is our array of strings. It returns the name that was the longest. Okay, so that's a little bit of work. I will leave that to you as extra credit. How about that? If you want to write a complete working program that implements this method and demonstrates it, in other words, you need a main to show me that it works, then I will give you extra credit. With that, we will bring this long video to a close. Thank you for watching. Bye-bye.